Tēnā koutou katoa. Good evening, everyone, and welcome to Hopkins Lecture 2021. Each year, the University of Canterbury, in partnership with Engineering New Zealand, invites an eminent leader to speak on a topic of public interest related to engineering or technology. This year, we are absolutely delighted to bestow that honour on Dr Rod Carr, who will speak on the topic Will Science and Engineering Save Civilization? Dr Carr has held high-profile leadership positions in the private and public sectors. It's very well known to us here at the University of Canterbury, having served as Vice-Chancellor here for 10 years. So may I extend a very warm welcome to you, Rod, and to your family members. My name is Larry Bellamy, and it's my pleasure to co-host this event with Cameron Chapman, Chair of the Canterbury branch of Engineering New Zealand, and Cameron will run the question session after the lecture. Just some very quick housekeeping. Could you check, please, that your mobile phones are turned to silent? Bathrooms can be found on the ground floor of this building, and in the unlikely event of an emergency, the nearest exit is the main door of this building facing Crake Road, which you probably came through as you entered this building. Before I invite the Vice-Chancellor of the University, Professor Cheryl Delaray, to introduce our speaker, I'd just like to make some comments about the Hopkins Lecture. The lecture was established in the 1970s in honour of the late Harry Hopkins, who was head of the Civil Engineering Department at the University for 27 years. I think it's true to say that civil engineering absolutely flourished under his strong leadership and started at its rise to being world-class. And it's also true to say that I think we are benefiting from Harry's legacy even today. So it is my real pleasure to also welcome the Hopkins family members who are here tonight and to thank you for your continued strong support of this event. So without further ado, could I invite the Vice-Chancellor to introduce our speaker?
Tēnā koutou katoa, good evening. And if I may take the opportunity to say the legacy is a very strong one, because in the short time that I've been here as Vice-Chancellor at the University of Canterbury, we're very proud to have civil engineering feature in the top 10 best engineering departments in the world. And that's been repeated year after year. So I wish to acknowledge that legacy and long may it continue. It's an honour for me to have this opportunity to introduce our speaker for the 2021 Hopkins Lecture. Dr Rod Carr, as we all know, was the Vice-Chancellor of the University of Canterbury for a period of 10 years. But that period doesn't speak to the enormity of the leadership challenge that he faced in that decade. I think it's true to say that it's rare across the world that a Vice-Chancellor has to take on the responsibility of completely rebuilding a university campus and at the same time keep it running as the university is being rebuilt. So Dr Carr did a sterling job as Vice-Chancellor of the University of Canterbury, and I had the benefit of coming into a newly built campus and one that continues to offer very high quality education and research that makes an impact locally and globally. But over and above Dr Carr's sterling leadership as Vice-Chancellor of this institution, he has had extensive experience in both the public and private sectors in a number of roles, including management, leadership in general, and governance. Prior to his term here, 2 terms as Vice-Chancellor, he was Chief Executive at Jade Software Corporation. With respect to governance, he served as Chair and Non-Executive Director of the Reserve Bank of New Zealand, and for a time he was acting Governor of the bank. Dr. Carr was the founding chair of the National Infrastructure Advisory Board for over a decade and was also non-executive director of the Canterbury Employers Chamber of Commerce. He has a list of accolades that are too long for me to read out, as it's not my role to take up too much time. But I do want to say something about his educational credentials. He has a PhD in insurance and risk management, an MA in applied economics and managerial science, an MBA in money and finance, and honours degrees in law and economics. Dr. Carr is currently serving as chairperson for the New Zealand Climate Change Commission, He Pou e Ranga, and he serves on the boards of Otakaro, ASB Bank, and the Christchurch Arts Centre. So it's now my absolute pleasure to invite Rod to present the 2021 Hopkins Lecture with the thought-provoking title of Will Science and Engineering Save Our Civilization? Rod.
Ina mana, ina iwi, tēnā koutou katoa, ko Rod Carr, kai whakahaere He Pou New Zealand Climate Change Commission. Thank you for the introduction, Cheryl. It is a privilege to be here, as well as a pleasure. To the Hopkins family, who I have yet to meet, a delight to know that you are here too. I'm provoked to start by observing that the first of the Hopkins lectures, I believe, was given in 1978. Doesn't sound like that long ago for some of us, 33 years. How much can happen? Did we know in 1978 that Rob Muldoon would be elected Prime Minister? That we stood on the eve of massive deregulation of New Zealand's society and economy? Did we foresee in 1978 the collapse of apartheid, the end of the Cold War, the reunification of Germany? Let alone could we have imagined the personal computer, the cell phone, and the internet? So when we come to think of time, and when we come to think about our circumstances and what might change, it is easy at the same time to both underestimate what could happen and perhaps to overestimate how little is likely to change. So tonight, I thought I would take the opportunity to round up some of my learnings and experiences from the past 2 years. Because when I was approached in September 2019, but 2 years ago, to put my hat in the ring to take on the responsibility for chairing the yet-to-be-launched New Zealand Climate Change Commission, I stated quite clearly to the Minister and those who would have me put my name forward that I knew nothing of climate science, nothing of climate policy, and I was not a climate activist. The Minister thought that made me eminently well qualified to chair his new commission. For I knew little, came with little baggage, and because I was unknown to many stakeholders with vested interests in the work that would be done, I guess they weren't too alarmed at the prospect that I might chair that commission. But in the last 2 years, I have come to understand much and to understand how little I understand. But I've also come to understand that the science has been known for a long time. A woman scientist in America in the 1850s, Eunice Foote, is credited with having done the first experiments to be recorded, which concluded that the level of carbon dioxide in the atmosphere would have a blanketing effect on the Earth's surface temperature. Of course, a Swedish guy was credited with that work in the 1890s, and it took until the last 15 years for the footnote in history to have been uncovered and given the appropriate recognition it deserves. By the 1960s, the petrochemical industry, which employed some of the best science and engineering graduates and practitioners in the history of humanity, concluded that at the rate that we were extracting and burning fossil fuels in the atmosphere, but more dramatically at the rate we were increasing that action, we were terraforming. We were changing the planet's climate in the decades, not the centuries, to come. That report was provided to the then President of the United States of America, Lyndon Johnson, who was busy fighting a war in Vietnam. And not surprisingly, as we so often see, short-term priorities dominate some of the long-term needs. And it wasn't until the early 1990s that the world came together, when the science was conclusive that no single actor, no single industry, no single nation state alone would be able to change in the way that we needed to change a core part of the civilization we had built. And yet it is estimated by some that half of all the greenhouse gases that have ever been emitted by human activity have been emitted since then. We are changing the climate as was predicted. The science has got more robust, the findings more certain, the predictions more accessible. But the fundamental truth is that the combustion of fossil fuels in the atmosphere, along with the emissions from our agricultural activities and other greenhouse gases, have already contributed to a rise in our planet's surface temperature, estimated with a high degree of certainty to be in the order of 1.1 degree from pre-industrial levels. And at the current rate and pace, by the end of the century, that'll be +3. And what makes us so interested and slightly anxious about this temperature rise? Because it is true that there are times in the history of this planet when the surface temperatures have been warmer, when there has been more carbon dioxide in the atmosphere than there is today or likely to be this century. But here's the rub. The geological record shows that the planet's surface temperature on average appears to have oscillated between -4 degrees Celsius and +2 degrees Celsius from pre-industrial levels for the last 300 million years. The geological record has no record in that period, not only of average temperatures being higher than +2 degrees, but at any time of temperatures rising at the current rate. And it is the rate of change that poses the greatest threat to ecosystems that are unable to adapt and adjust in normal biological time. So I don't want to dwell this evening on the matter of the science. 80% of New Zealanders, according to a number of surveys, are willing to accept that the climate is changing, that human activity is the cause, and we need to do something about it. I'll leave you to sort out the other 20%. So we then have to begin to address the issue of what can we do and what will we do. It's pretty clear that each and every one of us individually, each of our families, each of the businesses and organisations we work in, each local government, national government and global organisation has to play a part in first understanding and then reducing the emissions from their activities. But this is no trivial task. And it's worth remembering, it has been estimated that one single barrel of oil, 166 litres of oil, does 10,000 hours of labour. The current price of oil in New Zealand dollars, that makes 1 hour of labour done by the combustion engine in one form or another worth 1 cent per hour. The technology for the discovery, extraction, processing and use of fossil fuels has been extraordinary. It has enabled us to roll back the night. It has enabled us to liberate ourselves and beasts from the burdens of work. And today we lift 80 million barrels of oil a day and combust it in the atmosphere. We've created a civilization which, among many attributes, is energy intensive and hyper-connected. And if we are to preserve that underpinning of our civilization, then we are going to need to develop and, more importantly, deploy alternative technologies quickly. This afternoon, in a panel discussion, it was interesting to see the weight of evidence move away from the we have means of to what is holding us back from making the changes we need to make. And so that's the topic I'd like to focus on, and in a particular New Zealand context. Because it is easy to say what others ought to do. It is easy to shame and blame others. And it is easy to believe our own hubris because it may be convenient for us to do so. But it is important to remember that every country needs to be held accountable for its contribution to global warming. So what is New Zealand's contribution to global warming? Well, it's 0.17 of 1% of annual emissions. And some would say that's a good reason to go home now. It's little, the world wouldn't notice, we could go bankrupt trying, so don't we get a get out of jail free card? There's 100 countries in the world who either as a proportion of global emissions or in their total emissions are equal to or less than New Zealand's. And together, we, that 100, contribute over 20% of global emissions. So do we all get to take a free pass? Or just some of us? It's also the case that on a per capita basis, our emissions, gross emissions, are in the order of 16 tonnes for each of us each year of CO2 equivalent, global warming potential, 100 equivalency measure. Let's not go down that rabbit hole. However, even if we set aside all of our agricultural contribution on the grounds we're feeding the world, and I'll come back to that in a minute, it still leaves 8 tonnes for each of us in our emissions, of which about 40% is transport. More importantly, China, 5 million tonnes per capita, and they count all of their manufacturing and agriculture. India, 4. It's not unreasonable for other countries to look at us as rather greedy in our claim on the world's limited capacity to further absorb greenhouse gas emissions. Oh, but some may say, we are feeding the world. Yes, it's been estimated that the protein produced largely from meat and milk that is sold to other people could feed 40 million people out of 8 billion. So I don't believe the hubris that we're feeding the world. We are feeding some people. And it has been pointed out by some observers that the people we're feeding typically are middle and upper income consumers, who in many cases live in countries or societies that over-consume protein. We are not feeding the hungry, even if we are feeding 40 million. And of course, it's important to remember a couple of little telltale facts as we think about why we need to think about agriculture. The first one is that it has been estimated that there is about 20 kilos of greenhouse gas emissions and GWP 100 equivalency per 1 kilo of beef and lamb, about 10 kilos of greenhouse gas emissions per kilo of milk solids, and about 5 kilos of greenhouse gas emissions per kilo of chicken or pork. So even if the world needs to eat meat, A, it doesn't need to eat as much as some of us do, and B, it doesn't need to eat the most emissions-intensive forms of protein that we produce. So the wake-up story for New Zealand agriculture is don't believe your own bullshit, because at the end of the day, foreign regulators, foreign consumers' preferences and alternative technologies pose a much greater threat to the business model of ruminant pastoral agriculture than any local regulation or any political party might choose to address. We also like to think that we are contributing less to global emissions because 80% of our electricity is generated from renewable sources. This is factually true, and it is helpful that it is such a high proportion. But if we are to decarbonise ground transportation, low and medium temperature process heat, we are going to have to substantially increase our generation of electricity from clean and renewable sources. That is going to require a substantial amount of capital, a significant amount of skills, and time. New Zealand might like to believe we have an abundance of renewable energy. And while it is true that relative to our population, we have an abundance of potential renewable energy, to realise that energy is going to require deliberate policy action. Leaving it to markets and prices alone is likely to lead to misallocation and inefficient and late allocation of resources, given the lead times and regulatory impediments to building out the generation capacity, the grid network, the smart technology that will enable the deployment of the devices that will help us decarbonise our economy. If we then come to some of the other challenges, there are many wagons that would like themselves to be hitched to the climate change engine. And it is important that we're aware of the fact that climate action happens in the context of a wider agenda of social issues. Affordable housing, child poverty, family violence. None of these things are going to go away, and none of these things are going to directly be impacted by the need and investment in a decarbonised world. But one of the risks to our pathway to a cleaner, greener, healthier, less vulnerable and more resilient world, one of the barriers is the alienation and disaffection of key stakeholders in our society, who, for various interests, may miscalculate the risks, be over-optimistic about alternative technologies, be hopeful that someone else will be asked to do more, or that they will be left to do their bit later. That myopia, that inability to assess risks, that capacity we all have for denial, linked with a predisposition to obsessive and compulsive behaviour to protect the way we do things today, pose some of the greatest challenges to mobilising our minds, our leaders, our wallets to decarbonise our society. So, the theme of this address, will. It's a will, not a should, not a can, but a will. Science and engineering, will knowledge and the application of knowledge save our civilization? I'm a pragmatic optimist. What's that? I like to believe we will. I think the alternative is rather depressing. I like to believe we will because the predisposition is towards survival. And because I've become convinced we can, if we choose to. The tricky point of this is timing. If we wait long enough to be abundantly certain, not only that we need to, but how we are going to make the transition, in all probability, we will be living with avoidable consequences. That the least probability of regret is to move sooner and take a tea break later, rather than to obfuscate, deny, and delay action in anticipation that something cheaper and better will turn up just in time. For New Zealand, we do have options, but we are going to face some challenges. The world will look to us to play our part. The world looks at a country that is blessed with choices. We have chosen not to use nuclear power. Some countries have no choice. We have chosen not to dam any more major flowing rivers. Some countries don't have that choice. We've currently chosen not to use gene editing to create low emissions fodder or address ruminant pastoral emissions. We've chosen to vote ourselves some of the cheapest but highest emitting motor vehicles available today. The world looks at us and says, you're a free and independent nation, you're smart people, you're well educated and well informed about these matters. You have ambition. You've declared an emergency. And we understand your right to choose what you're going to do. We don't agree you have a right to choose not to do your share. So how would you determine what New Zealand's share would be? Paris Agreement fortunately did raise that topic, because when the top-down approach of Kyoto failed and the leave it to markets model was corrupted, the Paris Agreement believed that the only alternative was a bottom-up approach where each nation stepped forward and self-declared its own target for emissions reduction, and that through regular accountability in front of the wider global community, nations would be encouraged and ultimately required to take the necessary action. New Zealand's nationally determined contribution, as agreed to in 2015 under that Paris Agreement, was that we would reduce our greenhouse gas emissions from all sources from a gross level in 2005 by 30% by 2030 to net emissions in that year. That 30% reduction we are not currently on track to achieve. That 30% reduction is achievable with action, but every year we delay makes it less likely it can be attained. Our nationally determined contribution is made up of two parts: what we do through domestic action and what we do through offshore mitigation. That is where you pay somebody else to do more than they were reasonably expected to do. We've always expected we'd pay somebody else. How much we pay, how much we miss our target by through domestic action will only be known after the fact. In November this year, the Minister for Climate Change will take to COP26 in Glasgow a new commitment by New Zealand, a new nationally determined contribution that without any doubt or spoiler alerts will commit New Zealand to a larger than 30% reduction on a gross net basis from 2005 levels to 2030. And by May next year, we'll determine what proportion of that is likely to be achieved by domestic action and what will be left over to transfer wealth from New Zealand to a foreign entity. Domestic action is made up of two parts. We've had a split gas target in which we seek to reduce biogenic methanes by an absolute amount, and we seek to reduce net emissions of all other long-life gases to zero by 2050. If we achieve the reduction in biogenic methane of 24 to 47% and net zero all other gases, at the bottom end of that range, the 24% reduction, New Zealand will still be contributing 28 million tonnes a year of greenhouse gas emissions in 2050. At $250 a tonne, that will be a wealth transfer in that year alone, which could be in the order of $7 billion. There will, of course, always be a question: who should pay? Taxpayers, future generations, the emitters? Well, time will tell. But in the meantime, we do need to move forward with a plan, and a plan that will bring society along with it. So when it comes to the question of will science and engineering save our civilization, which bits of our civilization is it that we must save? Our participatory parliamentary democracy. I think most of us would want to tick that. Our views about the rights and roles of individuals and individual accountability and responsibility, and how in our society we preference the individual over the collective. Other societies choose not that. In our society, we seek inclusion and participation, but that often comes at a cost of time, delay, compromise, consensus building. In our civilization, we've put a very high value on what costs least, not necessarily what has the likelihood of least regret. In our civilization, we discount the future heavily and back ourselves to find a way out if we find ourselves somewhere we don't want to be. All of you will have a different list of things that you would hold dear and attribute to our way of life, our civilization. What are we prepared to trade off as we move to maintain the energy intensity and hyperconnectivity that is also part of our way of life? Can we have it all? Can it be just as it is today but different? Can it be we all have privately owned and operated vehicles parked in the driveway, but now they are low and no emissions vehicles? Could it be that we can find alternative low emitting agricultural products that give us the same sensory perceptions as our current lamb chops and beef steaks? Or will we have to be willing to change? Often young people have asked me, so what can we do? We aren't directors of companies. We don't have large research budgets. What can we do to make a difference? And there are 4 things which not only young people, but all of us can actually do if we choose to do it. First one, learn and understand. There is no reason why every New Zealander cannot discover the simple truths about the impact that they have, we have, our businesses have, our choices have on the environment and what our emissions are. understanding that as a first step, all of us spend money as consumers in a consumer society. Every time you spend money, you vote to have that product or service put back or replaced. If you choose not to spend on things with high emissions, things that have damage to the planet, things that adversely impact the climate, voting with your dollars will change what is produced and consumed. Understanding the provenance of goods and services, their entire supply chain, is beyond many of us as we stand in the supermarket. But increasingly insisting on simple and clear representations of facts that matter is something we can all subscribe to. Where we work matters a lot. It's surprising how influential staff can be on the predispositions, understandings and attitudes of middle and senior management and business owners. Understanding the supply chain and channels to market. Making sure that you don't greenwash your business and its services and make only the claims that are truly robust and defensible will likely not only endear you to your customers, but is likely to protect you from the litigious society that we are. And of course, it does matter what we vote for. In a participatory democracy, we will get the leaders we choose, and they will give us what we've asked for. And if we ask for more short-term expediency, obfuscation, delay and denial, if we presume magic will happen, technologies will arrive, and markets alone will deliver in time the changes we need, well, if that's what we vote for, that's what we'll get. But the optimism is that as an open society, we can learn. We do listen. We have opportunities in this country that many countries don't have. And not to use those to play our part would be truly, truly selfish. So in my little journey over 2 years, understanding a little about climate science, something about climate policy, it is with frustration that we look at the attempts to actually take action that would have meaningful impacts on New Zealand's greenhouse gas emissions. Our modest attempts to do what the Europeans did over 10 years ago in imposing standards on emissions from motor vehicles. Our modest attempts to use markets and prices through subsidies and premia to adjust accessibility to low emissions technologies. Our modest attempts to signal and advance the direction of travel for agriculture, all of those things are necessary but not sufficient for us to embark with haste on a journey that we owe our children to. So imagine a world in 2050. I'll be 92. I intend to be around because I want to know how this turns out. My twin grandchildren will be 32. So they'll be really conscious of what's happened. But like I am back to that 1978, remember? We could have created, and only if we choose not to, will we not have created a cleaner society. Combusting fossil fuels in the open air is a dirty business. It has collateral damage in our health, and the waste products achieve nothing. It could be a greener country. Yes, we will sequester carbon in plantations of timber, and we will use some of that timber in our biofuels and our building and construction. And we will sequester carbon in slower growing, longer life natural forests. It's extraordinary to remember that in the 1850s, 80% of the Canterbury region was covered in forests. Today it's less than 20%. And in fact, in the 1880s, there were more than 20 sawmills operating 7 days a week on the Canterbury Plains. I'm not suggesting we should put it all back, but putting some back would seem prudent. A cleaner, a greener, a healthier New Zealand. There is no doubt that while they are difficult to identify and measure with the rigour that the science might demand, that we have created a relatively unhealthy society in the way we use energy, generate that energy, provide our food, and the quantities of it we consume. We also have a vulnerability to a long supply line for liquid fossil fuels. Reducing that vulnerability will be a positive for New Zealand. A larger proportion of locally generated energy that is distributed around New Zealand and used locally can only advantage New Zealand's risk aversion. And we will be a more climate resilient society. Why? Because in the process of adopting the technologies that will reduce emissions, we'll be plugging in to the new world of science and engineering as the rest of the planet moves along that curve. We need not be the first, the bleeding edge. But by being late, by being trapped with old and obsolete ways of working and old and increasingly obsolete technology, we will disadvantage ourselves in the latter part of this century. So it is in our self-interest to develop and adopt the new low emissions technologies. Now, much of this speech has focused on mitigation, that is, the need for and activities that can and the barriers that might prevent us from reducing our greenhouse gas emissions as we go about our daily lives. But there is another blinding truth. We have already baked in climate change. And even if we were to rapidly reduce emissions, in the most optimistic scenarios now, there's another half, possibly more than a half of a degree Celsius warming coming our way. And while some might think an extra 1 or 2 degrees on a winter's day in Canterbury would be a blessing, many of you will know and understand that much is hidden behind averages. That an average rise in planetary temperatures of half a degree is associated with 6 to 8 degrees Celsius rises in some locations. That it will turn some marginally habitable lands to uninhabitable. And the speed of change will mean that agriculture conducted in some places will no longer be able to be conducted in those places. And that is if it all goes according to plan. So adaptation is with us, and we have some massive social choices to make. We are not going to be able to afford to compensate all the losers. We are not going to be able to make whole all of those who suffer losses as the warmer, windier, wetter, and in places drier climate befalls us. We have in New Zealand created a sense of collective responsibility when natural disasters strike. It happened in Canterbury. The country reached out. It helped that we were insured. But at the end of the day, there was a massive transfer of wealth from around New Zealand into this region to support this region's recovery. We're not going to be able to do that for the impacts of climate change. They will be too widespread, too all-pervasive, too expensive. And in some cases, losses will simply lie where they fall. So what is the nature of the social contract as we move from, if it wasn't your fault, then we are on your side and collectively we will support you, to we would if we could, but we can't? There are going to be major choices about what to protect and when to retreat. when to double down, and when to abandon investments. Some of those will be informed by technology choices, some by financial arrangements, some by power, those who have influence. Some will be good choices, and some will be bad choices. But let us hope that science and engineering are always in the room, always at the table, always able to bring knowledge and the practical art of applying science in front of the decision makers. Because if we chuck the science and engineering out, the civilization that we know will fail. On the note of optimism, I believe we will keep the scientists and the engineers in the room. I believe that they will make a significant contribution to mitigation and adaptation. I don't believe we have enough of them, so I need to do something about that. But I do believe that increasingly scientists and engineers are going to have to use a climate change lens to help look at every decision we make, as must every business owner, every politician, and every household. Kia ora.
Thank you, Rod, and thanks for staying up here to answer some questions. So it's now my pleasure to open the floor to anyone that has a question.
Ooh. God. Step out of that. Mhm. Yeah, so there's lots of challenging questions about this offshore mitigation. The first one is we won't know how much in quantity we're short till we look back. We won't know the price because there isn't yet a market. And we don't know who the counterparty is. So we don't know the answer to the question of who we're going to pay. The Paris Agreement provides for bilateral as well as global markets to meet offshore mitigation obligations. Switzerland has done a couple of deals with a couple of countries that are subject to independent verification. But the challenge of all of this is for it to count, it has to demonstrably be additional, that's the additionality, permanent emissions reductions that are auditable from the level that a country would otherwise have been committed to. And it has to be able to be enforced. So the idea that we might go plant trees in Ethiopia as part of our offset is just a joke, right? It's not a thing that's going to happen. So if enforceability and compliance are preconditions to parting with your money, as they should be, the reality is we are likely to end up doing transactions with countries like us. And get this, we may end up paying Australia. Because it turns out they've got a lot of options to decarbonise their economy. Yeah. Oh, well, that's nice to see the live stream. So I was trying to dodge the light. Right.
So we've got some online questions as well. So we're,
good.
This is being live streamed as well. So I'll just perhaps ask a couple of.
Yeah, you ask the questions. I'll do my best. If I don't, I'll get one of the audience to answer.
So one of them is around the use of nuclear energy to help meet some of our GHG reduction emissions.
So it's interesting, New Zealand's been able to some extent to rationalise no nuke, not only as a social policy choice, but on the grounds that the minimum scale for a modern nuclear reactor is large enough that it would supply a significant more than half of New Zealand's electricity need. And you wouldn't want to have all of your eggs in that basket, so you'd need another one as backup, at which point the economics of the thing fall to bits. The UK is spending £500 million on research to develop small-scale reactors. We know you can make them small because nuclear submarines have small reactors. The trick is, can you make them small and economic? And that's a technology path that the Commission certainly doesn't bet on or bank on, and in fact we assume we don't do any nuclear for New Zealand's energy. But if by 2040 or 2050, small-scale, affordable and economic nuclear reactors are available, and New Zealand chooses not to use them for social policy reasons, then the world will look at us somewhat differently. And say, that's your choice, but it's not an excuse.
Another one here, methane 70 to 80 times more potent as a greenhouse gas than CO2. So how might Aotearoa get to grips with this aspect of it?
So this whole thing about greenhouse gases, GWP 100, GWP star, biogenic methane, and there's papers coming out all the time about it. The first thing is that nobody debates that methane is a better blanket than carbon dioxide. Prove it in the lab, and that's known science. The question is, how do you calibrate by how much warmer it is? Because it's warmer when it first comes out, but it doesn't last in the atmosphere because it breaks down. So all of the gases have been equilibrated to this GWP 100, global warming potential over 100 years. And that became the standard, for want of a better or different standard, by which you equilibrated gases that were coming out of economies and societies. And under the GWP 100 measure, then the global warming potential over 100 years of 1 tonne of methane, whether it's biogenic or whether it's fossil methane, is estimated to be about 28 times 1 tonne of carbon dioxide over 100 years. If you bring that back to the first 12 or 20 years, a much shorter period, then you get the 80 plus number, because it is a much more effective blanket earlier before it begins to break down. So GWP 20, GWP 100, at least they're kind of similar. You're just debating about what's the time frame. Now, there's a new thing, or another thing around called GWP star, which is a special invention, and it looks at the marginal contribution from existing levels of a change in emissions. And so with carbon dioxide, you stick it up there and it sticks around for 1,000 years. So the only way you can deal with this is to sequester it back from the atmosphere or stop putting it up there. But biogenic methane, because it breaks down, you could hit a steady state of emissions. And so long as you were only emitting as much as the rate at which it was breaking down, you could keep doing that and you wouldn't be adding to global warming. But one of the little tricks in this equation is if you've got to reduce global warming fast, guess which gas you go after sooner? And suddenly you're not interested in GWP 100, you're interested in that GWP 20. So if we then look at methane and its sources, about 20, my recollection of the numbers, about 20% of global greenhouse gas emissions comes out of methane, about half of which comes out of the fossil fuels industry itself, largely as waste products from the production of oil, gas and coal, and about half comes out of agriculture. And the agricultural emissions not only come out of ruminant pastoral agriculture, they actually come out of rice paddies as well, when they do whatever they do in rice paddies and leave it all behind to rot. So the Philippines has an issue about biogenic methane, but they grow rice to feed their population. So they might not look so kindly on our view that we should grab the share of methane emissions for making lamb chops for high-value consumers in London. That trade-off around the world is what goes on in the great conventions, the one coming up in Glasgow, where no country alone unilaterally can determine what the answer to some of these questions is. What is your fair contribution? How is your contribution made up? What historically have you contributed to this problem? What technologies are already available that if you chose to deploy them could make your contribution greater? That's the conversation that goes on at Glasgow, not how little can you do, how late can you be?
Yeah, let's take some from the room.
Scotland and some other countries have done some work on tidal power. Is New Zealand doing much on it? I mean, it would seem to me a relatively simple thing. It's corrosion. Brilliant chemists can solve corrosion any old time. Sure, we'll lose a few whales, but what the hell?
So there's not a lot being done at the moment. You would have thought Cook Strait offered an amazing opportunity. There was a pilot program up in the Kaipara Harbour when they were making sushi out of dolphins on the ocean floor, but it's a bit unfair. But I think what the issue is at the moment is deploying solar and wind, and it's got its intermittency problem, but deploying solar and wind looks like having the lowest marginal cost in our current way of thinking about deploying power to the grid. You've got to ask who's going to pay to overcome the intermittency. Who bears the cost of the lake held in reserve? Because you can't just say to the wind farm and the solar array owner, you get full cop with no risk when you turn it off because the stuff didn't come on time. So that is why the Climate Change Commission said we actually need a 30-year energy strategy for New Zealand. We actually need to get the people, the players, all 40 of them, or it's a relatively small number in New Zealand, into a lecture theatre, sit them down and say, this is pre-competitive jousting. How are we going to design a system that gives enough certainty without eliminating competitive opportunity so that there is a roadmap for the development and deployment of multiple sources of renewable generation that can be plugged into the appropriate backbone of New Zealand with the smart devices so that we actually use what we generate, however we generate it, as efficiently as we can. Because we're going to need so much more of it that wasting it is the dumbest thing we could do. And then you've got the interesting question of that little bit of power down at the bottom of the South Island. And at the moment, decision rights about that lie with Meridian. They own the dam, they own the water in the lake, effectively, they own the energy in the water in the lake. And if they choose to block sell it for hydrogen production for export, they don't even need Overseas Investment Office approval. 51% in Treasury have told the government that they can't exercise their rights if it disadvantages the minority. Yeah. So, I mean, there are some institutional arrangements, and we look, wherever this climate action meets climate policy, you look at institutional arrangements as well as human behaviour. And those are some of the barriers that we have to get real about.
Sorry,
Yep. There's nothing that in my capacity at the Commission we've been alerted to. Offshore wind is more likely to come before tidal power. And offshore wind has some advantages because if you get 12 kilometres off Manukau Heads, you've pretty much got constant wind close to New Zealand's biggest urban area. So the Brits have basically given the world technology for offshore wind, and the Chinese gave the world technology for solar. We're waiting for the Americans to do something.
You used a phrase when you were talking about the excuse for delay and obfuscation, used if we wait for an abundance of certainty. And I keep hearing the phrase, in our government's current response to COVID, an abundance of caution.
Yeah.
How can we switch from, thinking about climate action and climate policy from the point of an abundance of caution rather than having to wait for an abundance of certainty? Is there something that scientists
There's a
and
phrase
engineers...
that I got taught in insurance economics, which is the probability of regret, which I think is actually very appropriate. If we delay and it turns out we should have taken decisions and moved sooner, what does that look like? And if we act early and it turns out we didn't need to go early, what world do we end up in? What does that look like? And all of the stuff I've seen about climate action is the probability of regret is low if you go early. The probability of regret gets high the later you leave this. So if you go early and you chuck a bit of money at things that turn out not to be needed because hydrogen fuel cells turned out in the 2030s to be better than battery electric. So you go, oh, bugger, wish I hadn't done that. But what if not? What if it turns out that the hydrogen fuel cells are great for heavy-duty trucks but not so great for light vehicles? So I think that idea of, it's not a symmetrical payoff. It's not a normal distribution here. There is probability of regret, and it is biased in favour of early action being least regret. And the notion of, finding the least cost is a unidimensional view of the complexity of what we have to deal with here. So I'm much more a fan of thinking about what does bad look like, what does good look like, what's the certainty on one state or the other state.
We'll jump back online for a couple more. So there's probably touching your economics knowledge here. So it's probably a societal answer as well, but is there a need to accept a lid on economic growth? And then how do we reconcile that with our concept of what amounts to success? Then there's a follow-on one that says, is the classic capitalism market kind of broken in this?
Right. So the first thing is this idea of growth is really quite challenging because there is this weird thing called GDP, which was created for a purpose, not the purpose for which it's now being used. So gross domestic product is a measure of busyness in the market economy in a society. So first you have to be busy, and then the busyness has to be in a market economy where it's measured. And so it has always seemed strange to me that if you live in an ambiently warm climate and the room temperature is naturally 18 degrees, your GDP, all other things being equal, will be lower than if you live in a cold climate, have to mine coal, burn it to heat your house. All other things being equal, the cold climate has a higher GDP, more monetized busyness in the economy to get the same ambient room temperature. That just does not feel sensible. Right? But gross domestic product is important for one really important reason. Because it is monetized busyness in the economy, it's a proxy for the taxable economy. And so when we think about why are our elected leaders so concerned about gross domestic product, it's because gross domestic product tells you what the tax take at given tax rates will be. So we can have a discussion about growth and what we do with growth, but we have to come back to the real world, and the real economy is, are we prepared to live with less? And that depends where you are in the pie. Because I'm sure that the 300,000 lowest income New Zealand households are not that excited about not having more. And are the 300,000 most affluent households happy about having less? And the way we've kind of squared that circle has been, if we can make the pie bigger, the theory was you'd give a bigger share of the bigger bit to those who were least well off. That doesn't seem to have happened in the last 30 years. So let's come back to the capitalism story, because that often comes up, and there's a sort of gleeful look in the eyes of some people who rub their hands and think climate change will bring it all down. And this is the end of this nasty capitalist system. So I think I've got kind of bad news for them. If we think about capitalism as being financial capital rather than factories with machines, think of it as being a system in which we have created claims against future ownership of assets and future output that are able to be transferred between individuals and over time. That, in the essence, is the core of financial capital. Now, that has been around for 10,000 years. Ever since we first figured out cities and invented money, it got steroids when we invented credit, and it truly took off when we decided that we weren't counting anymore. And the social creditors should be clapping loudly, because we have created trillions of dollars of central bank credit in the last 10 years, literally by paper book entry. We didn't even have to print the banknotes. So financial capitalism, that is the ability to create a claim on future ownership and future output, is not about to go away. And we see it in China, and we see it in North Korea, and we see it in our society. What might get challenged is the private ownership of capital in the models that we currently have. And there's no guarantee that that will persist. There are forms of capitalism that don't adhere to private owned capital to the extent we have it. And when it comes to markets, my kind of punchline is market acolytes are essentially the foot soldiers or pawns in the game of financial capitalism. Financial capitalism will survive. Markets are imperfect at best, and they misallocate and misprice some very important things. Markets tend to be myopic. Markets are asymmetric in the way they think about low probability but catastrophic events. Markets are cash, not value constrained. So there's a whole bunch of things that I think we have to be honest about markets to make them the best they can be, but they cannot be everything.
Back into the room, please.
You mentioned that part of the solution is having scientists and engineers in the room when decisions are being made and things are being done. Do you have any advice for scientists and engineers to either get into that room or how they should conduct themselves when they're in the room to be somewhat more effective than possibly they were in the 80s and 90s and 2000s on this topic?
Yes. How to get into the room. Don't wait to be invited. It's never too soon. I'm reminded of what happened in the Exxon shareholders meeting more recently, where two climate activists managed to rally enough of the big money to dump two directors from Exxon's board and essentially change the strategy of one of the largest global oil empires. So never too soon. Don't wait to be invited. And when you're in the room, behave as a professional. Because if the room can simply marginalize you as, oh, that activist, that single trick pony, then your ability to make a relevant contribution to the broader agenda that will be discussed in the room will be lost. So it is back a bit to the old polymath. You can't just be the climate activist at the board. You actually have to be able to fill in the agenda and make a contribution rather than what is the single biggest issue of our time. But I do genuinely believe all of us need to begin to look at our actions, our investments, our purchases, the way we spend our time through this climate lens.
Andrew Hopkins, Rod, thank you for your presentation. Just wondered if you'd comment on population growth and whether that might be a factor. If we could limit it, then we might be able to take us back a little bit.
Yeah. So population growth does get raised from time to time, and I put it in two contexts. One is the local, one is the global. So Then the demonstration path that the Climate Change Commission used to look out to 2050, and I have to be very careful, this is a demonstration path, it's not a forecast, it's a set of internally consistent modelled assumptions, and it's probably not a description of the state of the world that it'll be. But under that demonstration path, we used Statistics Department population projections and Reserve Bank and other economic forecasts. And what we see is New Zealand's population rise from 5 to 6 million extra people living in New Zealand. Is that plausible? Seems likely. Seems likely it could be 9 million. It seems likely it could be 5 million. Depends what we do largely with border control. But the planet won't notice. An extra million people living in New Zealand, whether they're our children or migrants, the planet won't notice. And the planet's population is estimated to rise to about 9 billion by 2050. The problem is not a large number of people living with low emissions. The problem is the growth of the middle class, the 1.5 billion who live like us wanting, or the 1 billion who don't quite live like us, aspiring to live like us. And that growth of the middle class cannot be sustained using the technologies and emissions and resource depletions that have got us to where we are. So that is the tension. It's not so much the absolute population level, it's the expectations within the populations about what resources will be available to them to support their health and education, well-being and welfare. And that's much harder for us to have a sensible conversation about, because that's not about, oh, more people being born in China. One of the things to remember about China is that their generation of single-child family is estimated to have reduced China's population today by 400 million people from what it would have otherwise been. So they are the only country that could truly say they had done anything about population growth. But I'm not certain we're prepared even to consider what they did. So then you come back to, well, if it is about population growth, what we do observe is that the wealthier and better educated a society becomes, the less likely they are to need, want, or be able to afford large families. And the need, want, and able to afford large families is probably a better way of getting the total population to reduce. Coincidentally, it's a better way of aspiring to want to be in the middle class. I don't have a simple answer. I did get a bit of pushback when I said to one of those questions, well, have you ever thought of having your grandchildren sterilised? But that didn't seem to go down too well. We're all happy to talk about somebody else's responsibility to control population.
I just want to try and wrap three together that are online. I'll come back to you. So there's a theme here around kind of providing some proactive ideas. One of them was, could you clarify, you mentioned there were 4 things that we could do. And the first one was clear, which was learn and understand.
Yep.
The following 3 weren't quite clear. So perhaps if we
restate them. Somebody's notes, right? Yeah, the first one is know and understand. The second one is essentially make sure that when you go out and buy things, you recognise your money as a vote for that thing to be put back. So if you're buying a high emitting greenhouse gas intensive product or service, like flying to go skiing, the more you buy that, the more likely it is it will be provided. If you stop buying it, it is less likely to be provided. Then there's the employment relationship and advocacy, that you can be an advocate and you don't have to be marching up and down the street kind of thing as the general population. You can advocate for a climate lens or a climate impact effect in your workplace, wherever you are working. And you can look back down the supply chain to the business you're working in and forward to the channel to market to the end consumer. So it's not just limited to my factory. It is actually, where do we get our stuff from, and are they doing as much as they can, and how do we move our product to the end consumer, and are all the pieces in that channel doing what they can? And the final one is we get what we vote for, right? If you're old enough to vote, if you like the way the world is, you vote for more of the same, you'll get more of that.
come back in for one last question.
Cool, thanks. Perfect presentation. Thanks, Rod. I was wondering about the young people, the younger generation. Are things changing within the schools, or are there things that are happening overseas that we can use
Yeah,
coming up that aren't engineers?
the young are really, and it's very hard to talk for the young because I'm not, right? But the observation is that they are some of the most articulate, most well-educated people that I have seen, right? The smartest of them are truly smarter than I was at that age and stage by a country mile. I do remind some of them that we've lavished a lot of money on them. However, that said, we've got something for the investment. They do, I think, collectively, those who are engaged and active on this topic, feel that time is not on their side, do feel that early action can unambiguously make them better off in their future, and that delay and obfuscation is unambiguously bad for them. So at that sort of level, when it gets to the granularity of do you believe in feebates for cars, and do you think we should cull the cows, and do you believe, they're actually as divided as any other constituency about what should be done. But their sense of urgency and their sense of liability is quite telling.
So that brings the question session to an end. So as tradition for the Hopkins Lecture, we like to invite one of the family up to provide the vote of thanks for our guest speaker. So I'd like to welcome Bill, who's going to speak on the Hopkins family.
Of this even 5 years after our father died, it's wonderful. Special thank you to Emma, Emma Clark, for her organisation in this COVID time of changing numbers, and it's wonderful to know with that side that Emma said there were 500 registered on the live stream, the Facebook Live, so that's all wonderful. Thank you. And to Dr. Carr, that was the most wonderful lecture. Thank you so much. It was an honour to have you. And I think at this particular time, with the Commission's report just released and it's the time to have you deliver the report. So thank you very much for that. We've heard so much tonight. It's hard to know where to begin, but your knowledge and understanding and your pragmatic optimism, I think, gives us great hope that if we will do nothing, see what we need to do and keep science and engineering to the fore, that there is hope for us all. So I hope there's a lot to do, and we're hearing more from the Climate Change Commission, no doubt, tonight. But on behalf of everyone here tonight, and my brothers Tim and David watching this on the PG and on Norton on the live stream, and everybody else, a very sincere thank you. And
Pleasure.
There's a wee card from us, and I think there are going to be some trees planted.
Oh, hooray! We like
Yes,
trees.
yes.
Thank you. Perfect. Thank you very much.
Thank you, Jill. Very friendly words to close. I can't add anything more to that. But I'd like to thank the whole family. The idea and echo your sentiment as well for Emma. We get to see the front of all of these events, but we all know that there's someone in the background that does 90+% of the work. So please join me in thanking the Hopkins family, Emma and Rod, one last time, and that'll bring it close to the end. Thank you.